Welcome and thank you so much for joining us today for the Who's Who of the III webinar for this month. I am really excited to be joined by Brandon. Brandon is a professor in the MIIPS program and has graciously offered to share some of his expertise today. This session is going to be a little bit different if you've attended information sessions in the past. But because typically admissions runs those and they're very admission centric. But this is going to be a little bit of a sneak peek into Brandon and his teaching style and some of his expertise. So I'm hopeful that you'll be able to learn as much as I do. Without further ado, I'll turn things over to Brandon.
Sounds good. Thanks, Athena. And good morning, evening, afternoon. As you join us, we're around the world. I'm glad to be here. Thanks for the nice introduction, Athena. My goal for this morning is to introduce myself, a little bit about me. I'm an engineer. I like to geek out on airplanes, have some experience in aerospace, and so I want to talk about that, and then um, uh, bring that into the MIPS program, and particularly the couple of classes that I currently teach in MIPS, and kind of the philosophy, both as I look at things from my experience as well as we um, look to branch it out to the things that I'll be teaching and how I think it can be applied. So my hope is that it's a kind of a sneak peek to the classes and what to expect at MIPS, and uh, but also hopefully some things that get you thinking, so that is regardless of what you do, it you learn something and can take away. And with that, I did prepare a couple slides just as Athena invited me to introduce a little bit about myself. Okay, is my screen sharing all right, Athena? Great. So as we look here, I'm an engineer at heart. But more than perhaps an engineer, I see myself as a product developer. Somebody who doesn't just like the designing or solving problems, but really wants to look out, much like the students that come to MIPS, look out and say, okay, what's going on and how can I change something? It's, you know, do I like the math of engineering? Yeah, I like being able to figure out the answers, but I think there's two types of engineers in the world. There's those that are really good at the math, and then there's those that are really good at visioning what the challenge is and what can happen. I've had roommates that are really good at the math and they put in the equation, they find the answer, or I did okay with the math. But for me, I think my talent as an engineer was being able to say, okay, if I have this here and I move this here and I do that there, then this is the result that we get at the other end. That happens in mechanical engineering, happens in aerospace engineering, happens in processes and in production and innovation. And so um, I'm really that second type of engineer that I think can visualize what will happen and how things work. And then I'm really good at working with people that are great at the math or the metallurgy that can then solve the problem. And that's where I think most of the MIPS students fit in, whether they're from engineering standpoint or design or business, is we want to solve those big problems. And so my experience is in that. It's in product development. I'm an aerospace engineer by training. I spent 20 years working in research and development, and some of that was at research labs, corporate research labs, so internal R&D. Some of that time was customer facing, reporting up through the business and the marketing units and the product development and business development side as an engineer. And so I've seen how it works on both sides. And so with this 20 years of experience in industry, I I have a passion around what integrated teams can do and what they can accomplish. And so as I started teaching at the Integrated Innovation Institute, I was like, wow, this really works. And so, right, it's a chance to bring all those things that I'd learned in industry and then bring them and pass them along to good students like you who are interested. And so I have quite a few patents, um, even more internal trade secrets and some trademarked processes and that as I've worked through. And so the things that I share in class are as a result of this experience. And so I want to talk about, if I may, one of those opportunities this morning because I think it illustrates one the approach that I take in the classes, right? But also just the power that happens as we have an integrated team with business, design, and engineering. Me being on the engineering side, although sometimes I played business people in the meetings, so to speak. Um, but Ampliforge, and this is a press release from the Additive Manufacturing Trade Journal back from 2018. But this was working with my company and Airbus to develop new additive manufacturing technologies. And what is shown here, these are some views of a component. That component is about 2 meters tall. So we're not talking about really small additive manufactured chess pieces. We're talking very large components that are on the order of 100 kilograms in mass, 2 meters long that would go and be substantial portions of an aircraft. And this was brand new for us. I got to lead the development of what we were setting up as a brand new business unit inside the business unit. But I was doing that from the technology side, right? We knew the technology, but it's not enough to just have a good technology. We need to know what's the customer doing with it, what's the design. And so we worked very closely with Airbus engineers to understand what their requirements are and not just their structural requirements, right? Not just the material properties. This is the part that I'm showing here. It's titanium 6.4, Ti 6.4. Um, but it's not enough to just understand the material properties, but we got into to really understanding what's their manufacturing process. How do they build these? What are they hoping to do? And the goal in all of this was to really enable them to reduce their cost and their manufacturing flow time. And so there was a huge business component on the Airbus side and a huge component with their designers as they needed to make sure that it fit in with their processes, right? A little bit different than industrial design that we may think of as we look at our phones and other things, but still, how does it fit in with the processes and what the people will be doing? And ultimately, as it gets down to um, the the airline customers and the people that fly, and then on the business side, there's a huge side of it because Airbus was doing this not necessarily as a performance improvement, but as a cost savings. And so we needed to understand that and make sure we design our processes to meet their costs. Internally, we were also setting up a quasi new business unit to do this within the company. And so, right, we needed to understand what our business cases were. Um, as engineers, it can very often be easy to become enamored with the technology. Say, oh, I got a great piece of technology here. I can do this. I can do that. Um, but one of the things that I have learned throughout my career is that we need really smart engineers. They're the ones that develop this technology, that are passionate about the technology, as we can be. Um, the best engineers that I worked with are the ones that not only understood the technology and the opportunities that it brings, but have the capability to then translate that technology into what it means for the customer and to speak the customer language, or to translate that technology into what it means for the company and how it can solve a business case and how it can be profitable. So one of the big challenges here was this technology. At the time, I worked for a forging facility, and this technology had the potential to obsolete the forging facility in certain areas. And so, how do you get a group of forgers excited about a technology that could obsolete them, right? And so lots of exciting work that was done there as we were able to understand their needs. I talk a lot about understanding needs and people issues here, and that's because um, that's where I believe, and in my experience, we were able to truly be effective. It wasn't just in having a great technology, but it was being able to get everybody on board to achieve that. And that's the value that I see as we look at working with integrated teams. And one of the, I'll say, talents that I think I was able to develop and that I hope I bring to the classes. That's my goal in all the classes that I teach, whether it's the engineering core class or the capstone class, is making sure that we all can communicate well among those integrated teams. Um, and so if there's engineers, I try to teach the engineers how to speak non-engineer, right? But importantly, as we look at integrated teams, I don't know what the backgrounds are of you folks here on the call, but you may be business, you may be designing, and I think it's important that you can then speak the language of the engineer, right? And because fact is, as product developers, as the types of people that come through MIPS, which I expect you are, you're going to want to develop cool solutions as well. And so you're going to be leading teams. And as you lead those teams and take those leadership roles, you need to understand and be skilled and trained in how to bring all those various disciplines together, because sometimes that can be challenging. This is a picture that I like as we look at airplanes is in the middle is the airplane that the people want, right? The one that will actually work. Um, but every disparate group in engineering uh, believes that they are the most important, right? If I'm over here, if I really like aerodynamics, yeah, that's what we want, right? Or the engines, um, or the maintenance group. It has doors everywhere because then it's easy to get in and work on, right? Um, this expands out to, right? You get the designers in there, you get the business people in there that are just worried about, oh, what's it going to do to our work in progress or our capital? You know, the designers are really good about making sure we remember the people. Sometimes the designers come up with really great designs that just can't be built, right? And so, although this image it's humorous, at least for me as an engineer, um, but it's also real life. And as MIPS students, we get to learn how to manage all those things to bring them in. And my experience is that anymore in life, everything is a system. We have to work with others, and the MIPS degree helps us do that. So, right, as we look at the engineering class, I try to be very practically applied, right? There is some math, but as I've already shared, I'm not the mathy engineer. I'm the guy that likes to envision what's going on and figure out how to make it happen. And so, this is a unit where we're talking about heat transfer, but I always make sure that there's an application, right? So this is um, a very expensive hair dryer that some marketer has figured out how to take value from some engineering technology, build it in with the design, and make a case for paying more for a hairdryer because it can dry your hair more quickly. And I think it looks cool. You got both of those. I don't do a lot of hair drying, as you can see, but I've been told that it works fairly well. Um, but right, and so we'll have those discussions as we look to practically say, okay, what was the engineering role in this? What was the business role? What was the design role? And how do those come together to solve those problems? And so looking for real life applications to work with teams, both setting up to be challenging for the engineers, as well as doable and challenging for everybody else in a way that can be interesting and improving. And I don't, for the word that comes to mind is edifying, right? As we all come up to that next level together in our skills as we work to work with these teams. One of the fun parts of the engineering class is as we learn some of these initial skills, then we get to take something apart. Everybody takes apart something different. This is something from last year, where in that we get to practice all those skills that come together, right? Where the non-engineers who consider themselves non-engineers get to be an engineer and push on the engineers a little bit, and we get some experience in that integrated team. All of this comes forward to the Capstone project. And this is just a screenshot from a really cool concept that one of the Capstone teams came up with a year or two ago. And this was for a corporate sponsor as they were looking at options to have personalized and modular shelters outside, right? You don't get all that from the screenshot here. But the fact is in Capstone, we have corporate sponsors that come in that give a really good challenge, and then you get to work as an integrated team on the design. As you can see, the design here is pretty good. There's definitely not engineers involved in the design because it actually looks cool, whereas with engineers would be concerned with the structures and everything else. And the business side and the engineering side is they came forward and came up with a really innovative concept um, for a company that sponsored the project to enable backyard structures that were flexible and met their needs. And right, this is the pretty picture that they came up with, but behind it, they had good engineering plans on how to build this. And that came out of an integrated team where the engineers, the business people, the designers were able to come together and really understand the challenges and bring it to the point where a company could then take the ideas, take the plans, and run with it. And the reason that it's successful goes back to the things that I mentioned at the very first is because the engineers and the business people and the designers understood and worked together as an integrated team and spoke the language and pushed back and challenged each other and brought something forward that was really cool. So with that, I think I'll wrap up my conversation, my one side of the conversation. And is it all right if we open it up for questions now and another discussion, Athena?
Absolutely.
I would like you to expand on some career outcomes for taking such an integrated program
Yeah,
and what I should look out for in terms of building skills towards my goals. Thank you.
yeah, great question. So, coming out of the MIPS program, I see uh, a lot of career options, right? So if you're an engineer and you're looking for career options within engineering, right? There's the opportunity to lead product development teams, to lead internal research and development. Um, even and then as we expand out, right? There's opportunities in business development or product management. As I see it, anybody that's working with customers or new technology that's looking to build something or innovate or solve problems. Um, it's from an engineering side, it's one thing to know the technology, but you also need to know how the business works, right? Because you're going to be working with multiple people in the company and customers are the same if you're a designer, right? You need to work with the engineers and understand those. And so as I see it, the degrees, some of the job titles I mentioned, right? But more broadly, it gives you the opportunity to build your career within those or other places where you want to innovate or bring about new ideas or start new businesses because you're able to see things not just from your area of expertise, but more broadly and be able to collaborate more effectively with others. Does that help answer your question, Lois?
Yes, please, you have. Thank you.
You're welcome. So it looks like there's a question in the chat. Yeah, okay. So just looking at it, if I understand the question there, it's um how do we bridge human-centered design thinking with technical product development? And there's challenges there, right? And I think the from my experience, the challenge that I see perhaps is companies or individuals that, at least from a technical standpoint, that focus just on a really good idea without understanding where it could be used or the problem to be solved. And I think that that's, from the user experience and accessibility standpoint, you many times are focused on the people side. So how do we bring those together? And so I think one of the challenges, stepping back, besides just looking at the technology, having integrated teams is helpful here. As a member of a team with your user experience background, um, being able to effectively communicate throughout the organization that this is important and this is how we can integrate the technology to be successful, and recognizing that doesn't have to be an either or, but there's multiple solutions. Many times I think technical organizations get hung up on the technology and they fail to and a really good idea, and they fail to really understand the human challenge, the human values that people are looking to address. I don't know if that's the biggest challenge, but that's a challenge there that I think as user design background and that can then be bridged as you're able to help others see why people are important, and not that the technology is not important, but that there are ways to apply it that then bring greater value to more people.
So the next question I see in the chat is what's the difference between the MIPS in person and the MIPS online? And that's a really great question. So the MIPS program has been offered in person for the last 23 years, I believe, since the early 2000s. Again, entirely in person. And it evolved a lot over the last 23 years. Originally, it was just a very condensed 9-month option. You started in August, you graduated in May. It tended to be the best fit for those who had some work experience already because of the fact that it was just like really intense. Paused your work life, did this 9-month program, went back to work. But after about 10 years or so, we added in what we call the MIPS Advanced Study. It's a 16-month track within the MIPS program in person that allows you to extend that duration with an internship that you do in the summer and a final fall semester, which is largely elective driven. There's one class which is more independent and focused on what you're passionate about and individual curiosity. But again, largely what that MIPS Advanced Study 16-month program is comprised of is building on the internship and additional electives. Again, the program is always evolving. So in 2022, we decided to create an option of the MIPS program that could be completed entirely remotely for those who didn't have the flexibility to uproot their lives and come to Pittsburgh for 9 or 16 months. There's a lot of similarities. The learning outcomes are the same. The degree that you earn on your diploma, both will say Master of Integrated Innovation for Products and Services. So that's the same. There's still an industry-sponsored capstone in both in-person and online options. Some of the big differences. One, we built the MIPS online program off of the 9-month program. So there's no internships and no electives, right? So that could be a deciding factor for you. If you want an internship, if you want electives, you're going to want to do in person. And the classes themselves look a little bit different. We didn't just throw a camera in the back of the room and throw everything on Zoom and say, now it's online. we actually kind of took the learning outcomes and put them into these buckets that became certificates. So you earn the MIPS online degree by stacking together 4 certificates plus the final capstone course. At the end, again, you've earned the same degree, you've learned the same skills, but you've done them in a very different format. So those are some of the things that are key differentiating factors between the in-person option and the online option. Um, and while you're still typing your questions, I'm going to sneak in a question, Brandon, because again, my focus is always kind of on the admission side, and I know you're on the admissions committee. So what are you looking for from those, particularly from an engineering background, that stands out to you that says this would be that type of engineer, or this would be a student who would be really successful in the MIPS program?
Great question, Athena. So as I go through the engineering admissions, um, as we look at the primarily the portfolio, I'm looking for people that have an interest in engineering and are able to demonstrate that creativity and the ability and willingness to try to solve problems. Right? I don't expect the portfolio to be like a design portfolio. If some of you are familiar with those that are really polished and everything else, because that's not who we are as engineers. But as engineers, we're looking at how are we applying technology to build things to solve problems. And so that's what I'm looking for is the ability to think and to think critically and to question. And then what do you do with those questions, right? And hopefully you're uh, in the portfolio and or in your work experience, you're able to show how you've solved problems and how you've addressed them, whether it's in software or mechanical engineering or whatever, right? I'm not so concerned that, you're a scientist per se, but rather that you're able um, to be curious and have done some interesting work that you're creative with to bring something to life or to work towards that. How does that sound, Athena?
That sounds great. Thank you so much.
Yeah.
I feel like people worry sometimes that they don't have enough research, they don't have enough internships. So, all right, a question from Violet. I work as an AI researcher, and I often talk with customers who are excited about AI but aren't quite sure what it really means, what it can do, how it can help them. Do your classes touch on how to communicate or translate those kinds of ideas, or do you have advice for engineers on building that skill?
Yeah, so we touch on that in my classes, and that actually gets touched on throughout the MIPS curriculum, which is really understanding what people need and what people require, right? And so as we go through the engineering course, as we look at that, yeah, we'll talk about how we translate those to engineering requirements, but more generally, if we can understand and really get good at asking those why questions and be curious, um, then that comes in all of the classes. That's the foundation of the program, I think. And so yeah, we talk about it in these classes and advice that I have for you on developing that skill is to just practice asking questions, be respectfully curious, right? As we go back to the project I mentioned on working with Airbus, a lot of our success was in really understanding why they were asking for what they were asking for. They had a requirement that made not a lot of sense to us and increased the cost by about 30%. And so as we continued to probe and ask, we were able to realize what their real problem was. They weren't so much concerned that we did it in a certain way as much as we got an answer that let them know the part was safe to use. And so by doing that, we could change some things and have a solution that cut 30% out of the cost, which made it work. And so that's the integrated with the business and the engineering on the understanding. And to your point, Violet, is right. It's as we understand what they need beyond what they're telling us, then were able to come up with solutions that solved the problem that they didn't really know what they had. Because many times people have problems, but they don't quite know what it is. Henry Ford said if he asked people what they wanted, they would have said faster horses. But he was able to get down deeper. And um, so those are some of my thoughts. And yes, we do talk about that quite a bit through the program. And Capstone will give you a great chance to practice that over and over.
I
Thanks
love
for the
that Henry
question,
Ford
Tyler.
example. I'm glad you brought that up.
Yeah.
Yeah. And I would just reiterate again, sometimes when you're looking at graduate programs, you can get stuck in the mindset of, oh, this is going to be like theoretical and research and very like academic. And our program is very applied. You're
Yeah.
going to get so much hands-on experience with these types of challenges. And just doubling down on the communications component, practice with presenting your concepts, your ideas, and being able to respond to those questions. While you're thinking or typing, I'm going to ramble a little bit with some wrap up details and information. But again, feel free to send in your last minute questions in the last minute or so. But know that Brandon is just one of our incredible faculty members here at the Integrated Innovation Institute. We do have opportunities to hear from others coming up, so keep an eye on your inbox or our events on our website so that you could register to learn more from other faculty members. But also, there's a whole community of individuals, myself and Caitlin are admissions representatives who can answer admissions specific questions. And we do have ambassadors who are current students who could answer questions about life as a current student. They're the ones that have, moved potentially across the globe, who've gone through the application process themselves, who are taking these classes, who can talk to you about, the good, bad, and ugly and all of it. So I would definitely recommend if you do have those sorts of questions, booking time to chat with them because that can be really helpful. Okay, I do see one last question. Is there an opportunity to connect with faculty, demo classes, or do any kind of volunteer research? So that was one of the things that I was trying to kind of address with this Who's Who series as a way to connect with faculty. So we have another one coming up on November 20th. It's actually going to be a joint session with one of our original co-founding members, John Kagan, and an alum named Rebecca Pinn. And they'll be talking more about innovation, the innovation industry. So again, I'll be sending out information on that soon. That's another great way to connect. And we do have opportunities for you to visit class. I'm going to do my best to do two things at once and pull up the link. So if you want to visit in person, I just dropped a link in the chat. If you fill out that form and indicate your preferred days that you want to visit and what you're hoping to accomplish, our admissions officer, Caitlin Stossel, can coordinate that visit. And again, let you know what classes might be good to visit. But I'm not familiar with any volunteer research opportunities. Brandon, correct me if I'm wrong.
I'm not aware of any either.
Okay, great. Okay. I'm hoping I rambled long enough. But I wanted to just say thank you to all of you who joined today. Again, I think this was really insightful. Again, a huge thank you to Brandon for sharing his time and his expertise. Feel free to reach out if you have additional questions, and I look forward to seeing your applications come through.
I look forward to seeing them as well.
Okay.
Thanks, everybody.